Hello world. This is Callas Software speaking. My name is Dietrich von Deggern. I very much welcome you to another release of our secrets from the support vaults. Usually this is being done by our distributor by name. Usually it's being done by David, who is almost on vacation today. So it's going to be me, Dietrich, and
Mark Heusmann, who is sitting just beside Dietrich, and being here for asking or forwarding your questions. And I think I have some questions regarding the topic as well.
Yes, Mark will, as he has said, try to ask your questions, which means either he just thinks about what you might want to ask at the very moment and he will just do so, or you let him know what you want to know via the questions or the chat features of GoToWebinar, and then he will bring up your questions right in this webinar. Other than that, I have prepared some content about the topic as of today. This is Berlin, and the topic is actually fonts.
I don't see your slides.
You don't see? Okay.
So now we see it.
Okay,
perfect.
got it. So there was nothing important on my slides so far, just the intro slide. Let me see. No, that's that one. And then we are here in Berlin, as always, quite close to the TV tower. And the topic as of today is fonts. And since this is about secrets from our support vault, I thought, okay, maybe I should just start with a support case. And this actually is one. This came in, and guess why? Because a customer complained about these small black rectangles over here at the top and at the bottom. That the big one, another black rectangle here, but that I have created here just to protect personal data from the end user actually of this business card. But the other rectangles here, in fact, they also protect some personal data, but they are not here by purpose. So something went wrong. And many of our support cases actually are related to font and text. And this webinar is going to introduce you to what actually we want or what we are actually doing in order to find out what the real issue is here. This is, and I rather want to say that in the beginning, this is going to be more really technical stuff, so I try to walk you through one of the more complex areas of the PDF specification, which is text and fonts. But let's now see how that goes. So we have that business card here, and what you can do, might be a good idea, you have the file, when you open the file in pdfToolbox, actually it looks nice, it's looking okay, so you can't see these issues that we have seen before, but there is a profile that could help you to identify problems, list potential font problems, as you can see. And if you run that profile, you see that two things are found here, two warnings occur in pdfToolbox. One is encoding entry prohibited for Symbolic TrueType font, and the other, text cannot be mapped to Unicode. And now we want to find out whether any of these two entries might have to do with the text that was actually invisible later on when the PDF file was produced. In fact, if I double click on this first entry here, encoding entry prohibited and so forth, it would select on the page the text that actually created the problem later on. So that might be an indication of this. There is something related to this error message here that caused the problem. So, but I think, and in many cases I know that from users, this is not immediately clear to everybody what the actual problem is here. But there is already some explanation that pdfToolbox gives you. So PDF-A for archiving prohibits that a symbolic TrueType font uses an encoding entry. So another indication. So, but now let's just move on. And that brings me to the overview for today. Four different sections. First, I want to have a look into font tools in pdfToolbox. Then we do more theory. We're looking into fonts in PDF in general. Then I have some issues with fonts or glyphs, and we should know by then what a glyph is. And then we close with what we have started with some more font tools in pdfToolbox. I aim to do that in 45 minutes. Roughly, yeah, let's see how long that really takes. So font tools in pdfToolbox, I think a good starting point is the profiles that you find there that validate for PDF-X4 and PDF-A. At least these standards have been developed by ISO in order to make sure that a PDF file works in every viewer or PDF processor. So we may want to look into what is in these profiles, in these validation profiles. And another profile is the one that I've already mentioned, the list potential font problems profile. So, and then if we look into what these profiles, the validation profiles for PDF-X4 and PDF-A2 and the list potential font problems, if we look into what checks are actually set up in these profiles, we see that there are quite a few. First, we have a couple here of the ones that are in both PDF-X4 and PDF-A2. So for instance, character reference is notdef glyph. And I've already indicated in red here the terms that I want to explain in this webinar. Next one is the very same that we already saw with my example, encoding entry prohibited for symbolic TrueType font, and we are going to cover encoding, symbolic, and also briefly look into what a TrueType font is. Font not embedded, I think that is probably clear to everybody. Then we have a glyph in a subset font, so two other terms I want to explain. Then we have one here, more than one encoding in symbolic TrueType font, so we already covered a few of that, and so forth. And then we can translate these terms into questions. So what actually is a glyph? What is a notdef glyph? What is an empty glyph? What is a subset font? What is font encoding? Which font types can I have in a PDF file? So we mentioned TrueType, so are there other font types in a PDF file? What actually is a symbolic font? And what means a mapping to Unicode? And these are basically will guide me through the presentation as of today because I want to answer these questions. So first, and I'm using a pdfToolbox feature, explore fonts, that you can find in the tools menu of pdfToolbox, and that displays some information about all the fonts that are present in the currently open PDF file. And here I have three screenshots here, three different views. And in each of the views I have selected one of the glyphs in a font. And the first one here on the left-hand side shows us that the GID, which GID 52, which stands for glyph ID 52, has some outline here, and that appears to be a C. Oops. So actually a glyph, and that is the first answer that I can give, is a glyph is what you can find in a font and what holds actually the outline for a character. So if you want the appearance of a character. That is a glyph, and a special kind of glyph is the notdef glyph. And the notdef in this case starts with a dot, because that is something really special. The notdef glyph is actually something that shouldn't appear on a PDF file, and if it appears, it indicates a problem. So the very same that we have seen on in the support example, a couple of such notdef glyphs appeared, which basically means that the PDF processor was not able to find a glyph in the font that could be associated with the character code and the page description, and so it went back to this fallback glyph, which is the notdef, for there is no glyph being defined in the font for the character ID that is used on the page. So this is a fallback appearance, and an empty glyph is basically white space. So a tab or just a space or so, these are empty glyphs. So glyphs which have an ID in the font, but which don't have any contour in it or outline. Okay, so we answered a few questions. Another one was for subset fonts, and maybe a few of them know that. So a subset font is a part of a font. So when you embed a font into a PDF file, you can either embed all characters, so you just embed the full font, but in many cases you wouldn't do so. Actually, in most cases, the PDF Creator program would only embed the glyphs that are actually used on the page, mainly for limiting the total file size of the PDF file. So a subset font is basically a stripped font that only has a number of glyphs, and if everything went wrong, then it has exactly that number of glyphs that are actually used on a page. And we already can see that this could as well be a source of problems if a subset font would actually not hold all of these glyphs. Some may be missing. So, and then we already answered 4 of our 8 questions. So that is quite good, and we only used, 13 minutes for that, so that is fine. Unfortunately, in order to answer the rest of them, we need to dig a little deeper into font technology and PDF encoding for fonts and text. So let's have some look into what PDF says when it comes to fonts. So first, and I apologize for that there is that much text on this slide, but let me walk you through to it. So first, in the page description, so what you can call a content stream, so the description of the actual page in a PDF file, there you would find an internal name, in this example that is F25, then 12 defines the text size, and TF establishes that font to be the current font. And if in the page description I would then write some text, in this case F25, the F25 font will be used. That is a page description, and that refers to an entry, if everything went right again, that refers to a font object in the resources of that page. So every page has a resources entry, and this resources entry, if there is some text, it has to have a font entry, and that font entry, in this example, one of the font entries has to have the F25 name, and again some information where to find it. And that object, that font object here, has then some further information. So the base name, which in this example might be Courier. It also let us know what font type that is. It might be TrueType. The character width for each of the characters, so for each of the characters, the width, so that we can align one character after the other, taking the width here into account. Then it may also have the font itself. So the very font file that is on the hard disk of the one who has created the PDF file may be copied into this font file entry. So that basically is a data stream. It is, if you want, a foreign object to PDF syntax. It is referred by the resource font object here, but it's different. So the resource font object here in the PDF file has to be there when you use text. Optionally, that font object may have the font file itself embedded. And that is quite important to understand. When you embed a font file into a PDF file, you actually just take the font file as it appears on your hard disk or wherever and copy that into the PDF file. You may strip some information, but basically you wouldn't translate it into a PDF syntax. You would just take the font file as it is.
There I have a question. You write here for current page, but it can be, so I need the same font if I have a multi-page document for every page, or does the PDF embed the font file also for the whole document when I use, let's say in this case, Courier on all pages?
The resource object has to be on every PDF page, but it may refer to a font object that is shared between pages.
Okay, so I don't need a font for every font embedding for...
The font doesn't have to be embedded several times, so it can be shared throughout the PDF file. However, as I've just explained, the font file is different from the font entry here, and the font entry has to appear on every page.
Okay.
Yeah?
Understood.
And then finally, you may have, but again, that is important to understand, I will get back to that later on, you may have a to Unicode table. In this case, again, on the PDF level, you may have similar things in the font file, but you may also have one in a PDF file. And again, I will get back to that later on, why you might actually want to have that. But anyway, so here is a view on our Explore PDF viewer, and I'm just having it here so that you can see it, so that it's not so abstract what I've just mentioned. So you have a tool if you use pdfToolbox that allows you to have a look at the PDF structures here, and there you can see the internal name, the font resource object, I keep doing that, and then the information, the base name here, Quadrat sans bold in this case, the font type, type 1, the character width at the bottom, and then here, font file, that is the actual font. And in this case, it's type 1. And then I can, in the Explore PDF browser, I could open that here, and then it would display information about the, in this case, embedded font file. And that font stream entry here wouldn't be present for a font that is not embedded. And also, we don't see that here. We might have the Unicode table. So on the left-hand side, basically the same as on the slide before. On the right-hand side, the translation into what you can see in the Explore PDF viewer. So how does it now happen? So how is this information used in order to display text? So on the PDF page, you have a character code for each glyph that you want to paint on a page. You have a code in the page description. And that could be 1 or several bytes. It's a number. Basically everything in a file or in a computer is a number. But also here we have a number, and then that is being mapped to something, and that could to the actual glyph, and that could take place via an explicit encoding entry in a PDF. So something needs to be there in order to help us to how can we get from the character code to the glyph ID in the font. And then we could use an encoding entry in the PDF font object, or we use encoding as defined in the embedded font. So basically you could say, if you find in the PDF font object an encoding entry, then you have to look there. If that is not present, you go straight into the font and try to find your way to the glyph by using what is called the built-in encoding of the font. And then you have the glyph in the actual font. You can identify it there either by glyph name or by glyph ID. And then you have the outline or the contour that you would want to paint. So unfortunately, this is not the same in every case. In fact, there are several different cases. And this is, definitely one of the most complex. So the font thing is by itself very complex, and the encoding thing is maybe the most complex part of the already complex font thing. So just a few examples here. Type 1, for a type 1 font, this is rather straightforward. We have a character code, and then in the encoding there is make Roman encoding defined, and we can use the character code in order to translate that into a glyph name. So the encoding table that you can find in various specifications, including the PDF specification, would translate that into a glyph name, let's say capital C. And then you can, in a type 1 font, you have font names. Then you can just look for capital C in your type 1 font and you're done. Let us do the last one first, because that is easier. TrueType is always the most complex stuff. So we have a CID type 2 font, and I will get back to, I will talk about what font types you can have in a PDF file later on. And in the easiest case, you have a character code. Identity H is horizontal, actually, is defined for encoding, which means you can translate the code 1-to-1, and then so you can actually go with the character code into what is called the CID to GID map. The CID to GID map may again say identity, and in this very case it's actually so as you would want to have it all the time. The character code and the page description is actually the same as the glyph ID. But that is only possible for CID type 2 fonts. TrueType fonts, and again, these are all examples. So it could be different for a TrueType font or for a type 1 font. So these are just examples, and the reason why it's here is just to demonstrate that this is not straightforward. So you can forget everything that I'm talking about right after this presentation, but you should get a feeling that that this could be complicated. TrueType font character code. You have a custom encoding entry. So for each character code in the custom encoding that translated to a PostScript name, similar to the standard encoding here. But here we have a table in the font object on the PDF file side still, not in the font object itself. Custom encoding, we have got a PostScript glyph name from there. Then we could use the Adobe glyph list, which is a standard, and the Adobe glyph list maps glyph names to Unicode code points. So we can use that list that is implemented inside of every PDF processor. It's not part of the PDF file itself. The PDF processor just knows it. So, and then the PDF processor knows the Unicode value, and then if the TrueType font has a Unicode CMAP, we can use that in order to find the proper glyph ID. So far, now, and again, I mean, this is about how to find the glyph ID from the character code. And the important message is the character code in the page description is not the same as the glyph ID in the font, and there needs to be a way from this character code in the page to the glyph ID. And the way from A to B is not the same always. It very much depends on the font type and so forth. And for that reason, because it's so dependent on the font types, it actually makes sense to just right now look into what font types we could actually have in a PDF file. First, there are simple fonts, and simple means nothing is really simple when it comes to fonts, but they are simpler than composite fonts because they are only using 1 byte per glyph. And 1 byte means you can have a total of 256 glyphs, which is far enough for Latin character sets, but as we all know, far not enough for Asian fonts, or if you want to support several Asian languages with just one font, it's, you are off limits far. Anyway, simple fonts you can subdivide into type 1 fonts. I already mentioned that, and type 1 you can again subdivide in type 1 classic. That was the original font format that was invented by Adobe some time ago, and sometime later on Adobe created a more compact font format which has still the same basic structures and concepts, which is called CFF. So these are type 1. Then you have TrueType, and that was developed by that's not Adobe, that was Apple. This is wrong in this slide here. So TrueType was originally developed by Apple and Microsoft as a competitor to Type 1. So they had the operating systems, and they wanted to have better support for their operating systems, so they developed a TrueType. And then we have in PDF a certain type of font, type 3, and that is not a real font. Type 3 is a collection of glyphs still, but you would use PDF syntax inside of the glyphs. So you have other contour definitions in type 1 and TrueType. Yes, and in type 3 you would use PDF code, and they are rather rare, so you wouldn't find many type 3 fonts in PDF files. And then you have OpenType, which is basically a summary if you want, so you can internally, an OpenType font is in fact either a type 1 font or a TrueType. So technically inside there are either type 1 or TrueType with, if you want, some wrapper around. And then we have composite fonts. Here you could have more than just 1 byte, and then you can have more than 60,000 glyphs. And again, such a composite font is either a type 0 or a type 2 font. And then a type 0 basically means inside it's again either type, it is type 1 or CFF or whatever. So basically it's either the one thing that has been invented by Adobe, type 0, or type 2, then it's something that is very similar to TrueType. So summary of that is, in fact, from the real font formats that have been invented at some point, everything goes back to either type 1-like structures or to TrueType-like structures. So, and I have already said TrueType is the more complex one of the two, so I want to have one more slide on TrueType. As I've said before, all font types are either type 1-like or TrueType-like. TrueType compared to type 1 has some advanced features. And that basically goes back to the very fact that they have been invented by Apple and Microsoft. And the two of them actually wanted their operating systems to be as good as supported as possible. And for that reason, a TrueType font may internally have more than just one built-in encoding. So a TrueType font has at least one, but may also have several CMaps, character maps, CMaps. And each CMap would identify itself as being a MacRoman CMap, being a WinANSI CMap, or whatever. MacRoman for Macintosh, WinANSI for Windows. And then if the font says I'm using here MacRoman encoding, you would use the MacRoman CMap or the other way around. And just to be sure, to make that very clear here, there is another term, CMaps, which is just slightly spelled differently, that has to do with double byte fonts, with CID fonts. That is different. CMaps with a small c and a small m is a TrueType thing, while the capital C, capital M has to do with CID fonts, and we don't want to cover that in today. Another speciality of TrueType fonts is that it can have a couple of flags, and one flag may specify whether the font may be embedded or not. So a TrueType font can specify that it's not allowed to embed it into a PDF file. And another speciality is that it has another flag for symbolic. So a TrueType font may say, I'm a symbolic font. That means Saftingbats or Windings. A non-symbolic font basically doesn't have regular characters but symbolic stuff. We have an example on that later. So symbolic font, it doesn't make sense to use a symbolic font with standard encodings like MacRoman or WinANSI, because these encodings don't cover symbolic symbols. Yeah. And then one more specialty, I've mentioned notdef before, and because TrueType doesn't have font name, glyph names, by convention, the notdef glyph, it needs to be fine, and we don't have an encoding, of course, because we use a notdef. If we can't follow the encoding, then by convention the notdef is on GID 0. So what is a symbolic font? I mean, yeah, it's symbolic characters, not really characters, let's say symbolic glyphs. Here are things like symbol fonts, the Saftingbats, the Windings, and then if we enter using our keyboard ABC, using one of these fonts, we won't see A, B, and C. I mean, we could do for symbol because here are Greek letters, but not for the other fonts. And again, I've said it before, for that reason, it doesn't really make sense to use standard encoding, McRoman or Vinanzi with a symbolic font. One more thing to mention, really one more thing from this deep technical dive into font technology. So far I wanted to cover glyph lookup in fonts of a PDF file. And so far maybe we have succeeded and we are able to find proper glyphs and we can display everything on the page and then we are done. Actually, not quite. Actually, something is missing. And that is on this slide. So if we are able to line one glyph after the other, like here in the first line, text search, copying of text, we are able to write the glyphs onto the page, but we don't have a meaning of the text. So we have the glyphs, but we don't necessarily have to have in not every case we have information about what this glyph actually means, whether this glyph is a small letter T or not. So we don't know that. We only have that information if it would be possible to translate that glyph into a Unicode code point, because a Unicode code point, all the Unicode standards actually defines the meaning of all known characters. So, and important again is to understand that this is not a requirement of PDF. A PDF may very well just look nice on screen, but if you try to search for text or to copy text out of it, you just fail and see nothing or nothing meaningful. That only works if an additional requirement or additional feature is met that you can have in PDF, and that is the ability to map every character to a Unicode code point. How does that take place? Basically, it's similar to the glyph lookup. So again, we have some encoding, but here we don't want to find a glyph ID. Now we want to find a Unicode code point. Luckily, if we would use standard encoding like McRoman or Vinanzi, that comes with the encoding. So McRoman already says, okay, the glyph name for this character code is a small letter T, and then we are done, because we know that a small letter T is something in Unicode. So that is implicitly defined by the glyph encoding, the character, the glyph lookup encoding. Or you make that explicit. You can have, in TrueType fonts, you can have a certain CMAP. I've mentioned Vinanzi McRoman before. You can also have a to Unicode CMAP, and then that would translate from glyph IDs to Unicode code points, or in other cases you can use the Adobe glyph list. I said before, the glyph list translates glyph names to Unicode code points. Or finally, you can have another to Unicode table, this time not in the TrueType font, but in the PDF data structure itself. Important for now to understand, there is glyph lookup encoding, and then there is Unicode, and these are different from each other. And this is two screenshots from our internal, from our font report, so yet another pdfToolbox feature. And that displays here a certain font 1 here, which happens to use to have only 6 glyphs in it, and it can the glyphs can properly be associated with Unicode code points, and therefore our engine can write out the Unicode code points here. So actually you can see them, the U plus 0031 is associated with the Unicode, with a character with the meaning of 1. Okay? And in the font, it would use the CID 49 in this particular font. That could be different in yet another font. So, and here another screenshot from this font report, and here something went wrong. Same as with the glyph lookup, something can go wrong here, and the engine here found a number sign here, which makes sense, but this doesn't seem to be a dollar sign, and neither does this seem to be a percent sign. So just an indication that also here for Unicode mapping something may go wrong. So, and I think that is what I wanted to explain from a theoretical point of view. So what is a glyph and notdef, an empty glyph, what is a subset font, what is font encoding, which font types can be used in a PDF file, what is a symbolic font, and what means mapping to Unicode. So now I have some examples from our support vault, and these examples I want to use to show some problems. So the first problem is the missing glyph. So the page description references a non-existing glyph, so no glyph can be found in the font, which is either embedded or not. And then what are the reasons? Possibly it could be you have, when the PDF was created, a newer font version was used, for instance one that has the euro sign, and then a very old version of the very same font was used for embedding, and that didn't have the euro sign. Or subsetting went wrong, so the subsetting algorithm stripped too much away from the glyphs. So going back to our support case here, maybe now we can find out what the real issue was here. So we all should understand now that these rectangles here are notdef signs which the processor used because the processor was not able to find glyphs in the font. And it turned out that these two texts here were using open source bold, which is a TrueType font, and the TrueType font indicated that it was a symbolic font. And in the PDF, there was an encoding defined, which happened to be Wien-ANSI encoding. Now, as I've said, if the font would really be a symbolic font, it would contain symbols instead of characters. And if it contains symbols instead of characters, you can't use a standard encoding, because standard encoding is just about characters. Therefore, PDF specification says, if a TrueType font is specified as being symbolic, the encoding entries in the PDF file should be ignored. So that means you should ignore the Wien-ANSI encoding entry here. It even says if no proper encoding is present or can be found that works, so you can have a symbolic encoding, a CMAP in a TrueType font. So if no such thing is present, then it's application dependent about what actually happens. And this processor here actually, it very well followed what is specified in the PDF specification. It just said, in my application, I can't do anything. I have to ignore Wien-ANSI encoding, so I rather display notdef. And we ourselves, for this particular case, had to adjust our fix-ups and font engine, so we have done so already some time ago. So the cure here for this case actually would be to ignore the symbolic entry. Open source bold is definitely not a symbolic font. The font was mistakenly identified as being symbolic, and then you can use Vinci encoding, and then actually it turned out that the PDF file properly displayed the name and the address of Fußmobil here. Does it make sense? I hope so. Yeah, yet another example. Quite funny, long time ago, but we found it somewhere. It was an advertisement for fonts, and lucky, or quite funny. It says we have something against expensive fonts, and the company is called TrueType, and I'm sure they have very good fonts by now. So it's, but at that very time, very long ago, it happened to be when the advertisement was printed, something went wrong with whatever fonts they used at that time, so that a couple of notdefs showed up in the advertisement. So quite funny in this context. Another example here, we are again using our internal font browser. We have a TrueType here. It has character 0, and I said on character 0 there ought to be notdef. However, if we look at the contour here, that is not a notdef. That happens to be a small letter n. So, and then the creator of the PDF file would reference this character from its page description, and then there is no fallback character anymore. So actually this is not in accordance with the PDF specification, but it's being used, so you can find this stuff. And then glyph substitution, yet another ugly thing. So instead of a notdef showing up, a wrong glyph showing up. For instance, a PDF file creation software thinks it is using Vinci, while accidentally it defines it would use MacRoman, and then the glyphs are swapped. So example from, again, long time ago when you traveled to US, there were such problems. I mean, this is not a German character, or something went wrong here, the paragraph sign is in the wrong spot. This is another example that was an advertisement, and this is looking fine. Again, it's German, but look at the small letter n here. In some processors, the small letter n was replaced by a capital K. So again, something went wrong with the encoding here. One thing to understand, if you see these problems, they could have been introduced when the PDF file was created. Encodings were not properly used when either producing the PDF or rewriting the PDF, or using a notdef instead or for a regular glyph. But actually the more frequent reason here is that the PDF file is actually okay, but the PDF processor is wrong. So what frequently is the case, you have subsets, and we had the question before, we may have several pages, and each of the page defines a subset for the glyphs on that very page. And then you have, for each of the page, you have another font object, where the font object just has the glyphs for the page that is currently being displayed. Now, you may create single pages, for instance, and then you merge the single pages later on. And then it might happen that the subset fonts, okay, I forgot to mention, each subset font gets a unique prefix before it. So in this example, it's A, B, C, D, E, F plus, and then the actual font name. So this is by convention being done. Again, if you produce single pages and then merge them, it may be that this prefix is the same in the result file for each page, while the actual subset in the actual glyph subsets in these font objects for each page are different. And then if a processor just sees, oh, okay, I already got this font, I have it in my cache. I rather use the font in my cache instead of just deriving it again from the PDF file, then I'm faster. Then something may go wrong because although they have the same name in the PDF file, they are different. Now, it is so that the PDF file is just okay. As I have said, every PDF page has to have its own font resource object. It doesn't matter whether the font resource objects are, the name is then used on another page. That is perfectly okay. And the processor, the RIB or whatsoever, just needs to use the font object as present on the page. But that is not always the case, and it occurred frequently. And therefore we have in yet another pdfToolbox tool, we have a profile which is called Fix Potential Font Problems, and that would, in addition to each such font names here, it would just add another prefix for that in order to make it really unique. And that's it. That's it about the issues that I wanted to show to you. I have just a few more slides on other font tools in pdfToolbox. One is a fix-up called subset fonts, and another one on font reports. And we already had the first two here, the profiles, validation, pdfX4 and pdfA2, or list potential font problems. So again, it might be a good idea to just use any of these three profiles to make sure that font-wise and text-wise the PDF seems to be okay. And my goal with this presentation was to make you maybe a little better understand what the messages mean if you see any problems here. Anyhow, subset fonts. I think we already mentioned that, what a subset font is, but you can use the fix-up subset fonts. So you should all know what a subset font is. If you ask pdfToolbox to subset fonts, what it has to do is it has to look in the page description, find out what glyphs are actually used for the font, and then look into the font, whether all glyphs are there, and if some additional glyphs are there, get rid of them. While doing so, pdfToolbox would just rewrite the whole embedded font. So it would keep the font format for type 1, TrueType or whatever, but it would rewrite the font. And any minor issues with fonts might be cured by doing so. So that is a way to maybe get rid of problems, if you have some. And another tool, and that we had before, the font report here, just how you can create it. You have in a switchboard a section report, and there you have fonts, and that would create you a font report, and on each page of the font report you will get a summary of the font properties and all the glyphs in there, and whether the glyphs can be translated to Unicode and to what code points. So you have lots of information about the fonts as embedded into the PDF file. So, and then we have covered subset fonts and font report as well. I just want to mention that there are more pdfToolbox tools for really in-depth analysis of the inner PDF or inner font structures. I've mentioned these two in the course of this presentation. There is Explore Fonts and Explore PDF. And you will find them in the Tools menu of pdfToolbox, and you will also find related articles in our online documentation. And when it comes to font, especially the Explore PDF tool has a resource view, and that is provides lots of information about all the glyphs and have some indications or problems. So this is also for us, and we are here to unveil secrets of our support vault. So one of the secrets that we had so far is that we frequently use Explore PDF Resource View in order to find out what the reason might be for text or font problems that customers had reported to us in support. Okay, now we are done, and I was not as quick as I wanted to be, but I'm still within limits. So we covered font tools in pdfToolbox. Actually, we started there. We started with a support case, and then we looked into what pdfToolbox can offer. Then we had to explain how fonts are organized in PDF files. Then we had some practical issues from support or somewhere else with glyph selection or glyph lookup in fonts. And then we had some more font tools in pdfToolbox.